Let's now take a few minutes to look at the inequalities that can occur in triangles. And the first is called the exterior angle theorem. And what it says is that in any triangle, the exterior angle, like this one in red, is larger than either of the two remote interior angles. And the green and the blue angles are the remote interior angles, or the ones far away from the exterior angle. So this red angle is larger than the green angle, and this red angle is larger than the blue angle. And that's the exterior angle theorem. Let's see this play out with a numerical example. What I'm going to do is draw a large triangle on the screen, and I'm going to extend the third side. And I'm going to assign some arbitrary angle measurements. I'm going to call this angle 50, this angle 60, and this angle 70. And what that means is that the exterior angle must be 110 degrees because these two angles are supplementary. They have to add up to 180 together. And as you can see, 110, this angle right here, is indeed larger than that remote interior angle, and the exterior angle is also larger than that remote interior angle. So the exterior angle theorem holds. And I'm hoping you'll also notice that this angle, exterior angle, equals the sum of the two remote interior angles. The second inequality involving a triangle involves the sides. And what it says is that in every triangle, the sum of any two sides is always greater than the third. So here's a picture with side A, B, and C labeled. And what the triangle inequality theorem says is that sides A and B, when added together, have to be bigger than C. And sides B and C, when added, have to be bigger than A. And then when sides A and C get added, they have to be bigger than B. So all those scenarios have to be true. And a common question that's asked on problems is, if you know two sides of a triangle, for example, say they measure 7 and 10, what are the possible values on the third side? Well, we know that the third side has to be sandwiched between two extreme values. So I'm going to label the third side x, and it has to be less than the sum of those two sides, if it's the largest side, and it has to be greater than the difference of the two sides, if it's the smallest side. So it looks like x has to be stuck between 3 and 17. Any value for x within 3 and 17 would create a triangle. But notice here that I did not use the equality symbol underneath the inequalities because x cannot equal 3 and x cannot be equal to 17 either. The third inequality involving a triangle uses both the sides and the angles. And what it says is that in every triangle, the largest side is opposite the largest angle, etc. So the smallest angle is opposite the smallest side, and then the medium angle is opposite the medium side. So looking at this example, we can see that the longest side is CB, so the largest angle must be angle A. And then the smallest side is AC, so the smallest angle must be angle B. And then the medium side is AB, and it must be opposite the medium angle, which is angle C. So if we were to write the angles from smallest to largest in an inequality, we would begin with angle B because it's the smallest, and it is less than angle C, which is the medium angle, which is less than angle A, the largest of the three angles. And the converse of this theorem also holds true. If we know the order of the angles from smallest to largest, we can then order the sides from smallest to largest by using the opposite sides. The final set of inequalities involves two triangles. And you can see here we have a picture of two different triangles. And you'll notice that AB, this side, is congruent to DE, and BC is congruent to EF. And if angles B and E were congruent, then we'd say that these triangles are congruent by SAS. But what happens if angle B is not equal to angle E? And in this picture, you can see that angle B is larger than angle E. And what that means is that side AC, opposite the larger angle, is bigger than side DF, which is opposite the smaller angle. And this is sometimes referred to as the hinge theorem because you can think of these two sides as sort of doors on a hinge, And if these doors are open wider, creating a larger angle, then this distance between the other ends of the door will be larger than that distance right there. The converse of this theorem is also known as SSS. And what it says is this: if we know that AC is longer than DF in this diagram, and the other two sides are matching, then angle B must be larger than angle E. And that's simply just the converse of the SAS theorem.